Well, welcome everyone. My name is Neil Jacobs. I'm a scientist at CPAS and currently serving as the Chief Science Advisor at NOAA's Earth Prediction Innovation Center for the Unified Forecast System out of the Weather Prediction Office. Um, I'm delighted to have you attend the CPAS Discover Seminar Series. CPAS scientists do everything from explore the depths of the oceans to fly into hurricanes to heliophysics modeling of coronal mass ejections, those who unravel the mysteries of the Arctic. And we want to share all this with the public, the NCAR and UCAR community, and all of our colleagues at universities and agencies across the globe. So just to orient you all real quick, we're using Slido located at the bottom of the presentation screen. So you can pose questions for our speakers at any time during the seminar and they'll be answered after the presentation. At this time, it is my sincere pleasure to introduce to you today's speaker, Alison Gregory, who is a UCAR.CPAESS community engagement specialist working with NOAA's EPIC program and WPO. In this role, she is responsible for coordinating community engagement efforts of the UFS and EPIC program offices while utilizing social science strategies to develop and evaluate a sense of community among the UFS stakeholders. Alison has spent the past 10 years working on various projects that bridge the gap between social science and the environmental fields, such as watershed management, energy policy, and Arctic research. So Alison, over to you.
Thank you, Neil. That was a great intro, and thank you, UCAR, for this opportunity. I love that we are able to share our work all regardless of our different backgrounds, and that's something that we're going to specifically be looking at today. So as Neil mentioned, I'm the Community Engagement Specialist for the Unified Forecast System currently, and throughout my career, I've always been passionate about putting social science in places you wouldn't expect to find it. So I'm very excited to talk with all of you about this topic today. And before I get started, I want you all to take a moment and think about what social science means to you, and if you've ever thought about incorporating social science into an earth science project. And consider jotting down a few ideas if you already have an idea of the relationship between these two things. That's the thing about us social scientists is we're always trying to get you to write things down and participate. So I won't get a chance to hear what your ideas are while I'm speaking, but hopefully we can get a chance to talk about it in the future. So while you're watching this presentation today, maybe you came because you're already passionate about this and you just want to get a few more ideas, or maybe you're not really sure what social science is and how it relates to earth science at all. So my hope is that this presentation can have us all meet in the middle and we'll leave here with some great ideas. So what I'll be talking about today, first we're going to lay out what social science is and what some of the disciplines are and what kind of research methods that we use. Then I'll argue that two main ways social science can help the earth sciences more broadly, and that's to broaden the impact of your research, or you can improve your research process. And we'll see you can broaden your impact through communication and community engagement. And you can improve your research process through working on your team dynamics or reframing your research question. And then we'll conclude with some actions and ideas that you can take right now, and you can help your research team or your professional project or even your personal life. So let's get to it. So the first thing I want to bring up is that social science, while it's often described as a soft science, does in fact follow the standard scientific method that I'm sure many earth scientists are familiar with. Much like the earth sciences, social scientists need to get approval through boards and committees to ensure that the research is safe and that we're following the right procedures. So for us, that's the Institutional Review Board, or the IRB, that's most commonly used. And that's because that's the board that focuses on research with human subjects. So there are things we need to consider, like management of personal information, privacy, ethics, and I'm sure some of you have heard of some social research studies that have found to be unethical that led to the creation of these procedures, like the Stanford Prison Experiment or the Milgram Shock Experiment. Those are a few of the big ones. So those of us who use social science regularly, when someone says social science to us, that's actually really vague. A social scientist actually refers to a lot of different disciplines that don't always have overlapping interests or even methodologies. So, for example, I'm a sociologist, but that doesn't mean I have the same skill set as an economist or an anthropologist. So, with that being said, I'll be presenting from a sociologist lens, and other social scientists in different disciplines might present this material entirely differently. So, of course, there's more variation than just these few ones too, but I believe that these are probably the most common ones that'll come up alongside earth sciences. And as you see through this presentation, I'll try to sprinkle in experts from all of these disciplines when I can. And I won't go into detail about each of these disciplines. I just want you to be aware that if you're working with a social scientist, it might be a good idea to find out what their background or their specialty is before assuming that they can just work on any social science topic. Okay, so now that we know social science follows a scientific method and we know that there are lots of different disciplines, here are a few social science tools that could be relevant in this area. So the first thing we're going to look at is focus groups, surveys, and interviews. And that's probably what you usually think of when you think of what a social scientist does. And so this is when we ask people their opinions on certain topics, and a lot of times it's open-ended questions, but there's always a hypothesis or a question a social scientist is hoping to answer. So for scientists, this can be particularly useful because it can help us find out, is the public actually understanding the science that we're presenting to them? So this survey question on the left is a fun example for us weather nerds, and I'm sure this question has come up in conversations with many of you, with friends and whatnot. But in this survey of over 1,000 participants, they were asked that when forecasters say there's a 60% chance of rain for tomorrow, what does that actually mean? And we can see that the correct response was only selected by 19% of respondents, which is that it'll rain on 60% of the days like tomorrow. I also find it interesting that 24% of the respondents wrote in their own response. So there's implying that there's this public confusion about how do we actually interpret these precipitation forecasts. And what the interesting thing about this study is that they allowed these open-ended and write-in responses. So we were able to see the more nuanced way that people understand weather forecasts. So for example, not everyone who sees this statement thinks of it as a purely meteorological statement like some scientists would. So some people saw it as a more personal perspective, saying 60% of people will see rain, or there's a 60% chance it will rain on me personally. So allowing the write-ins for this study gave some actually nice opportunities for people to share how they actually thought the weather looked. So for example, they could give a correct answer just worded differently, like forecasts like this 6 days out of 10 will have rain. Um, so I thought that was a cool thing about this study. But this study was done from some of our excellent NCAR social scientists who I'm sure would love to talk to you about the great work they're working on. And it's just pretty cool in general that you can quantify and systematically study human opinions just based on uh, things that they tell us. So that's pretty cool. Okay, next thing we're going to look at is an economic analysis. And while previous tools, the surveys and interviews, those are used by many, many social science studies. Economists use tools that are a little bit more specific to their own discipline. So this social science studies human choice, which can involve money. So for example, how much are you willing to spend for a national parks pass? Or it could involve not referencing money. So an indirect use value could measure how do you value non-consumptive uses of a national park? Like, do you go for hiking? Do you go for fishing or to view the nature? These are both types of economic studies. So a NOAA research project revealed how much money a community could save with beach litter reduction. And the assumption here is that people spend more time and money traveling to seek out a cleaner beach. In this study, economists created an economic model that describes a person's decision of whether they would like to visit a beach or not. So they asked respondents to describe how concerned they were about seeing the marine debris on the beach, why they visited the beach, and how they just selected which one to go to. And they surveyed over 1,000 residents and measured debris on 31 beach sites. And so you can see on the right all the money that can be saved if you clean up a beach. But the cool thing I wanted to point out about economics is that they use mathematical models to create relevant variables to study. So a lot of times we think social science is soft and it's not really doing that much math. But in this study, they used a bunch of different variables to create one variable called travel costs. And so the point I just wanted to make here is that this is not necessarily that soft of a science. A lot of work went into doing this, and economics in general is a huge field that I'm not an expert in. So I will have a lot more resources I can send about on this topic. But it's especially relevant in earth sciences, especially when you're doing decision making for conservation or politics or financial strategies. And this is also a point I will shout out NOAA's Digital Coast resource, because they have a lot of information about how economic studies and how economics in general can be applied to coastal management, but that can also be relevant in a lot of different earth science fields. Now, the next tool is my favorite tool. This is social network analysis, and it combines quantitative and qualitative data collection to understand how resources and information flow through a network or through individuals. And so mapping these social relationships is a way that we can understand where there are barriers to collaboration and opportunities to improve connectivity in a group. So to give you an example, the image on the right here, this top right corner, this is a diagram which we call a sociogram. And in this, we can see that each person who can be connected to one another is connected. So this means that the network has reached a maximum number of ties, and it gives it a variable called a density coefficient. And so in this case, the density coefficient would be a 1, and then social scientists can then conduct all the normal quantitative comparative analyses of this kind of variable. So for example, a density coefficient less than 1 would imply that there's a network that has less connections than this one here. So that's just an example, but this methodology started in sociology, but that's not the only usage. My previous work, I used social network analysis in watershed management, but I wanted to share that this tool could also be used to study any kind of network, like they've done research on animal networks, where research scientists can use network diagrams to understand evolution behaviors, disease spreading, and even power dynamics in animal networks, which is pretty crazy. And so in my current position at UCAR, I'll be using this method to help with community engagement for the Unified Forecast System specifically. And there are also some plans at the National Weather Service to begin to use this method to understand how severe weather information can spread throughout communities when they're impacted by an event. Okay, the last tool we're going to look at is an impact assessment. And many of you might be familiar with this type of assessment because it can be done from a heavily scientific perspective, and a lot of projects actually require an environmental impact assessment. So we can think of this tool as bringing a lot of social science together to meet the needs of a specific project. So we would describe an impact assessment as a fact-finding mission or a way to think critically about a project before it happens. And even economic analysis can be included in that impact assessment. So again, this is really relevant when you're making policy decisions or planning projects before they happen. Also, of course, there are more tools that we can't talk about today. But there are case studies, demographic analyses, GIS projects, embedded observations, historical research. Really, the list of social science things you can do goes on and on. So now we learned about some of the tools, but why would you want to use these social science tools in an earth science context? Well, I would argue that it would broaden the impact of your research. So when we're conducting research, no matter what the topic is, we all hope to make a positive impact either on the world or in the field. So a first step in this process could be just jotting down a few ways that you think your research currently impacts people or social systems. And then maybe we can start to figure out how some social science methodologies could apply to that impact. So I'll argue that you can broaden your impact through community engagement specifically. So for example, surveys like the ones we discussed earlier, it can help you understand if your audience is really understanding what you're sharing. Um, Engagement is also a way to find out how inclusive your research is. I know some of you are working on projects that are highly technical, so it may be difficult to think about how your work relates to broader audiences. But just remember that earth science tries to measure things in the natural world, and the people are the ones doing the observing and the ones receiving your explanations. So try to always keep that in mind. Okay, so first, of course, I will talk about my current project with the Unified Forecast System. So the Unified Forecast System is an open access Earth system modeling platform. So that means anyone can contribute to the code or participate in running the model if they, have access to a supercomputer. So currently we describe our community as the entire weather enterprise working on Earth system modeling, which is a lot of people. So UCAR and NOAA thankfully recognized that this type of community was complex and their work could be improved if they hired a social scientist. So here I am. And I have been in my current position for almost a year, and I found that this community is tough to define and tough to coordinate, but it's not impossible. Social science research generally describes communities into 5 types. And these communities are action, place, interest, practice, and circumstance. And we don't have time to dive into all of these, but in the future, it could be good for you to look at these type of communities and see maybe what kind of community do you currently work in. So for us, the UFS is a community of practice, and this is because a community of practice is defined as a flexible group of professionals informally bound by common interests who interact through interdependent tasks, guided by a common purpose, and thereby embodying a store of common knowledge. So that's a big definition. And why does defining the type of community matter anyway? Well, I would argue it matters because when you bring in a social scientist, they don't have to create a brand new strategic plan for this community if you've identified what kind of community it is. Um, so for me, I'm conducting my research based on internationally recognized best practices of how to effectively grow and support a community of practice specifically. So there are methods that social scientists have already created, and we can just build on that work. We don't have to completely reinvent something when we're working on a project. So as you can tell, this is a lot of work, and currently, since the UFS is relatively new, we're mostly focused on the first row, which presents a lot of its own challenges. And so hiring a community engagement specialist or a community manager or someone who can create a comprehensive community engagement strategy would be great. But now I'll give you a few examples if that's not an opportunity that you have. Okay. So a common way social scientists are already involved in earth science is through risk communication. And this is another field that can cross a lot of disciplines, but the intention is to provide audiences with all the information that they need to make a decision, particularly as it relates to risks and hazards. So in this strategy, we're requesting feedback and opinions from the community as it relates to existing earth science research. So in this study on the left, social scientists are looking at the relationship between perceived risk or the likelihood of a tornado event related to how recently or how close a previous tornado was in the area. So social science can be useful here because it can help emergency planners and forecasters understand who will act in an emergency and who may need more time or a more urgent warning system. I also wanted to show you this example because it's a good example of how geography can be used in social science research as well. The image shows the paths of previous tornadoes and their strength with the black line. This is around Norman, Oklahoma. And the colors indicate how much individuals in that area perceive the risk of another tornado affecting them. So red would imply that you think it's highly likely you'll experience another tornado. And then the lighter yellow blue colors is you don't think it's that likely. So the point here is research shows that before people decide to act, that they need to know that they understand the forecast, that they believe the forecast applies to them, and that they feel that they or their loved ones are in danger. So studying tornadoes, of course, is an earth science topic, but the idea of what people understand, what they believe, and what they feel, this all falls into social science, and the impact of how people choose to act in these events can be a social science topic. And then both UCAR's Comet MedEd program and NOAA's Digital Coast program all have training modules that are specifically on risk communication. So if this is relevant to any of your projects, there's a lot of resources available there. Another way you can work on community engagement is figuring out how to reach more audiences. A lot of times when we're working on these projects, we're trying to figure out how to show the public that our work matters. So simple surveys and focus groups can help you understand what your audience is perceiving. But there's also been an interesting trend in trying to incorporate science into performing arts or using humor to reach more audiences. And this guy on the left, if you don't know him, this is Dr. Scott Denning. He works out of Colorado State University as a climate communication specialist. And he loves to say that climate change is simple, serious, and solvable. And so you can see how just taking the time to describe a topic in an approachable way can have a lot of impact. So even if you haven't heard of him, he's a great example of effective communication and public engagement on these kinds of issues. Besides, of course, there's always the more obvious pop culture scientists like Bill Nye or Neil deGrasse Tyson. Um, but another thing you can consider is citizen science, which is a new field, a relatively new field, where anyone can participate in collecting the research, regardless of their position or background. So could this be a strategy applied to the data collection efforts that you're currently working on? Is there a reason you need a scientist out in the field, or can this data be collected by anyone? Overall, the more eyes you have on your research, the more impact you can make. So another reason we might want to incorporate social science into earth sciences is because social science methods could actually improve the efficiency or accuracy of our research. So one way you can improve your team is working on your team dynamics. So over 90% of science and engineering publications are co-authored by teams of two or more. So there's a fairly new field of study called team science that has been developed to begin to understand how these teams work together and how can they be more productive. So one of the cool ways social scientists are beginning to look at team science is through social network analysis, as I mentioned, one of my favorites. And we saw before that it's useful to see where the gap in knowledge transfer is within your network and how could you improve these relationships. So I've used social network analysis in the past to understand how stakeholder engagement works in a watershed management setting. So particularly, I was looking at the relationship between small scale agriculture farmers and the Department of Natural Resource government managers and how that relationship played out. But social network analysis is also really useful in the medical field to understand how health information is spread throughout communities and how doctors share that knowledge that they have with one another. And so I wanted to reference that Divergent Science, this is a consulting firm that utilizes social science methods to help scientific teams identify where their knowledge gaps are or where their bottlenecks are and how they can be more effective. So an interesting thing they worked on is this theory about time turn taking and time spent talking. So this involves studying how often did people take turns speaking at a meeting and how much time did they spend speaking. So in this graph, you can see the that team 7, this is second from the right, they have one person who spent more than half of the time speaking, which I'm sure we might be familiar of a team meeting like that. But the farthest meeting on the right, this is team 8, they have a lot of turn taking and a lot of time where everybody got a chance to speak. So by just studying these kind of behaviors, you can see how well your team is doing in terms of collaborating and sharing ideas. So something cool to think about. How do you think your team would look the next meeting you're in? Maybe think about that. So social science is a great way to figure out how we're doing on these things. So the other thing we can do is reframe your research question. So let's take an example of a research question, and that is, what are the global impacts associated with climate change? That's a huge research question, right? But from an earth science perspective, we can see that there's a lot we could study. We could look at inland flooding rates, ocean ecosystem impacts, fishery yields, not to mention all the observed atmospheric impacts like global temperature levels, sea level rise, biodiversity loss, and it goes on and on. But from a social science perspective, you can see that there are even more areas we could study, like how have laws about climate change changed or developed over time? Where in the world are climate change impacts felt most by humans? And this list goes on and on as well. So you might not be a trained social scientist, but there are still ways that you can look at an earth science research question from a social science lens. And this would give you a more comprehensive, holistic perspective on your research question in general. So this image on the left is taken from the Intergovernmental Panel on Climate Change, the IPCC. And I wanted to briefly mention this group because it's a great international example of how earth science and social science can work together on a common goal. If we were to incorporate social science perspectives earlier on into our earth science questions, it could result in even better models. So you can see that some global problems like climate change, obviously they already necessitate an interdisciplinary approach, but that's not really the norm in all scientific research right now. So when we look at traditional science about climate change, a lot of times we look at the measurable rates of CO2, methane, greenhouse gas emissions more broadly. But even here, you can see that the models with future projections, they have to incorporate social science perspectives to predict what impacts we can expect to see. So social science topics like policy, human behavior, and economics, they're all crucial concepts if you want to understand what's going to happen from a scientific perspective as well. So they're not as distinct as you think. Okay, so now maybe you have a better idea of why social science could be important to your work, but I also wanted to leave you with some advice or action items that can hopefully help you right now. And this advice can be applied to your research team or your own professional projects or even your personal life. And as you see, we will talk about biases. So please note that these are my bias selections of some of the key ideas from social science that I think are valuable. But there are plenty more actions that you can take, and I'm happy to brainstorm with anyone offline if they'd like to. So the first thing you could do is incorporate inter or transdisciplinary practices. So interdisciplinary practice is when we're integrating two or more disciplines. So this could be as simple as using any of the methods you saw today, or even just a theory from a background that's not your formal background. This is what I've spent most of my career trying to figure out is how do we put these interesting social science methods in places that might be useful for environmental solutions. So this example here, this image is using natural disasters, and that's a great way to see how a lot of disciplines can overlap at once, because natural disasters can happen at any time or place. And of course, we need engineering and environmental science to understand these disasters, but ultimately they happen to people. So it can involve public health administrations, urban planning, or policy. So how can you incorporate other disciplines into your research project? And this could be as simple as consulting with a social scientist to see if they have any ideas or methodologies that could be useful to your work. Or you could bring a social scientist onto one of your projects or publications. I'll note that a lot of times people don't include an interdisciplinary angle simply because they don't see the benefit, or maybe their scientific frameworks are already too rigid to incorporate that. Um, but if you have that option, that would be great. The other thing is if you are professors in earth sciences, could you consider finding an article or one classroom assignment that's outside of the discipline you're teaching, but still emphasizes the topics that you're covering? The next thing you can do is something you can do actually right after this presentation if you want. And this is the Harvard Implicit Bias Test. And so an implicit bias is an attitude someone may hold that they don't know about, or oftentimes it's due to the culture we live in or how we were raised, and doesn't necessarily have to do with any of our core values. And commonly when we think of biases, we think of racial biases, uh, sexual orientation biases, but what might be more common in our field and in a working environment are gender science biases or gender career biases, or even age biases. So this is a fun thing you can do now, and it could inform just yourself and you don't tell anyone about it. You could do it with your research team and start a conversation. I'll share with you that this past weekend I did the Gender Science Association test. So I study this topic regularly, but I still had a moderate implicit association, and that was to males with more scientific roles and females to more liberal arts roles. So I don't want you to be embarrassed by your results. Like we said, implicit bias is something not that you hold consciously, but unconsciously. So it could be something interesting to look at. And again, this is a great emphasis of the differences between the social sciences. So on the left side, we have biases from a sociology perspective, but on the right side, we have biases that are from a psychology perspective. So these are a few, and I just pulled this infographic because I like how the author made it relevant to the workplace. But these are just kind of more things that you don't necessarily know that you're thinking about in your day-to-day life. So for example, did you choose a simple solution over a complex solution because you just wanted to save time? Or are you working on a project because you already devoted too much time to it and you're not committed to the results anymore? Recognizing these biases of yourself or your team could help your team become more productive. The other thing I wanted to briefly mention is the difference between equality and equity, because this comes up for social scientists a lot. And equality means that everyone receives equal resources or support, while equity implies that resources given meet the diverse needs of everyone. So I'll give you an easy example. So everyone's allowed to opt into a free text alert service to be warned about severe weather in the area. So that's a great example of equality. And equity would be ensuring that the community has access to cell phones with text capability, that they're able to understand the alert, that it's in their native language. If they don't speak English, how are they receiving that alert? And so just recognizing the simple difference could certainly improve your research. Okay, and the last thing you can do today, in my past presentations on this topic, my non-social science audience have really enjoyed this social vulnerability index. So I'll try to stay on this slide or take a screenshot. You can also find this slide on the CDC's social vulnerability index. But FEMA defines a social vulnerability as the susceptibility of social groups to the adverse impacts of natural hazards, including disproportionate death, injury, loss, or disruption of livelihood. So this table specifically uses 16 US Census variables to identify what kind of support communities need, particularly after a disaster. So they can pull all this information into one metric that can be compared across all US counties, and that's that map on the bottom. So that's pretty cool. The important takeaway here is that social scientists have already spent a lot of time researching what makes humans vulnerable. So finding creative ways to reduce this vulnerability can help us respond to disasters better and just support one another better. And in general, another thing you can think about is the term of social capital. So a lot of times we can think of social capital as the positive things associated with society. So your social relationships, and then the social vulnerabilities as things that make it tougher. So capital is access to resources through social networks and relationships. Specifically, this capital can connect you to information or opportunities, and it can come in a lot of different ways. So it can be economic, cultural, symbolic, or social. So think about how your research relates to these forms of capital. And while I say positive things, it's also important to consider that these forms of capital could be negatively used to affect decision-making or strategic planning. So, for example, in your research group, if reputation and loyalty, which we can see would be a symbolic form of social capital, if reputation and loyalty is more important in your research group than qualifications, like how would that affect your team dynamics? And also, if you need to convey your science to others, do you understand the cultural capital or the cultural dispositions and knowledge backgrounds of your audience? So knowing all these things could also be really helpful for the earth sciences. Okay, so I know I threw a lot of information at you, and hopefully you have time to digest, and we have time to answer some questions. I have an additional slide that has all the resources and studies we talked about today. So hopefully I can share that with all of you too, and I'm available over email if you want to talk about anything. I'd love to hear from you. So thanks for listening.
That was awesome, Allison. Thank you so much. So now on to the Q&A portion of the seminar, and I think we've got some time here. I'd like to direct everyone's attention to the QR code. You can see it on the screen right there. It'll take you to Slido. While you're doing that, I'd also like to invite you all to watch the webpage. It's cpass.ucar.edu/discovery-seminars for upcoming seminars. Our next one is scheduled for Wednesday, December 18th at 11 a.m. Mountain Time with Dr. Charlotte Waterfall, NASA Jack Eddy postdoc fellow working at the Goddard Space Flight Center. She'll be speaking on flares, storms, and space weather, tracing solar eruptions and their journey to Earth. We also invite you to find their talks and past talks on CPASS's YouTube channel.
It looks like we have our first question from Mary. I appreciate your work and talk. In particular, your risk communication map was very interesting. You can see who isn't noticing that they are in danger but actually are. How would you typically proceed with that information?
Yeah, great question. So, I'm happy to connect you with the author of that paper too, and I'm sure she has some interesting results there. But what I would say is that there are so many factors that go into something like that. So particularly in this study, there was a denser population area in that dark red area. So a lot of times it could be the amount of connections they have with other people. So for example, maybe a tornado came near them, but their house was fine, but then their friend who lives a little bit closer experienced a worse effect of the tornado. So that may have amplified their risk perception. But there are also so many other cultural things, like how often do they watch the news? Is the news that they're watching really fear-based, or are they more rural and they don't care to watch the news or know what's going on? And so there are all these kind of variables that affect how people perceive this risk. And so I think the goal there would be, if you recognize these areas where there is a significant earth science risk that's not being acknowledged, what's the most useful way to reach out to that community? So again, that might include more research where you're going into the community and seeing, like, they don't watch TV, they're not on social media, so you need to go to their local coffee shop and let them know about the tornado resources they have available and that kind of thing. So I hope that helped answer the question.
Okay, it looks like we have another one from Rebecca. Uh, Thanks for a really interesting presentation, Allison. Based on your experience so far, what do you see as a potential future for incorporating social sciences into work in your group or CPAS UCAR more broadly?
Okay. All right, two parts there. So I'll start with CPAS UCAR because UCAR ultimately has this affiliation with universities, which is really exciting. And so to me, when I have a future dream of where I see this going, uh, it would be those of us, our earth scientists and our atmospheric science disciplines at school. I would love to see a curriculum change where nothing major, but that you would have to have some requirement of incorporating a social science method or a project of some sort in all of these earth science degree programs. And that can also be something that UCAR, like through MedEd, they offer a lot of programs. And I think we are still kind of lacking in terms of this whole field. This was 40 minutes, but I could easily have, created so many training modules on this topic, right? So could we create some social science modules that would be useful on the MedEd side, on the UCAR side? Or can we just work with universities one-on-one to help them realize what kind of methodologies can be useful for their research? And then from my own work, I am hoping to my dream is to just have an entire social science team because as you can see when we go back to um, this work, I am only one person, and it would benefit from incorporating a lot of social scientists together in this process. And another interesting thing I'll mention is currently in earth sciences, we've kind of have this like islanded perspective where we bring a social scientist on because we know it's valuable, but then that social scientist is kind of an island on their own, and they don't really necessarily know what other social scientists are doing in the earth science fields, or we one-off meet each other and then we hold on for dear life. So I would also love for there to be a bigger community of social scientists working in this field, and how we can better share our results. I think that'd be awesome. And if Rebecca is who I think Rebecca is, she would be joining that team with me. So
Okay, we have another one. I really appreciate how the IPCC utilizes social science to simplify their findings for the public and policymakers. Can you share this kind of work for folks unfamiliar with it?
Yeah, so I'm happy to, I can add some resources if they're not in my slides already, but one of the cool things that the IPCC does, and I don't know if we compiled a list of all the disciplines they include, how it would look, but they have a huge, I don't know, 200-page report that they release on climate change more generally, very scientific. And then they also release maybe like a 15-page report, which is a summary for policymakers. And that is how they kind of get the more approachable stuff out of their media. And I think that's kind of a lot of the stuff you see on social media, you know, when you see on the news that like, oh, the 2 degrees Celsius, and then it's some cool graphic. IPCC is doing a lot of that work. So yeah, I would love to send along these reports because I am not a communications specialist, but there are definitely plenty of people who are making really cool graphics and trying to make this material as engaging as possible. And I hope it's having an effect. It's hard to tell when we're stuck in our day-to-day earth science realm.
Excellent, thank you. I would just add that I love that the IPCC rates things like how likely is something like this going to happen, and just kind of makes it very simple for folks, like very likely, not too likely, just kind of really simplifies things so that non-scientists can get a good grasp on what the science is saying. Um, if anybody has any questions, please add them now. Allison, do you have anything you would like to add about like the future work or your specific work with UFS that you have found helpful for people in terms of unifying the team and communicating better with the team and the public?
Yeah, nothing specific I can think of. The main thing I just really want to drive home is find your social scientists, you know? There's got to be one lurking close enough to you that you can utilize and see how it could be useful. I mean, even just go get coffee with them and present them with an idea, and they'll give you a different way to look at that. I think the biggest thing with joining the UFS community is that I came in from this perspective of not having a background in, I mean, you know, I'm an atmospheric scientist. I know how models work, but I don't have direct experience with the UFS. So I think the benefit there is it allowed me to understand both how the public may be engaging with this material, but also how people who are in the weeds are engaging with it. And just being able to bridge those connections, I think, is really important.
I I've got a quick question, Allison. So can you talk a little bit about data that's collected for verification of this work? And I'm curious from the I guess perspective of how do you frame questions in a way to sort of parse out people's understanding versus their response? Because I think, you know, for a lot of different scenarios in weather, there's a lot of different case specific things that people do. They may understand it perfectly and still not have the means to respond versus didn't respond because they didn't understand it, and basically all sorts of stuff in between. I'm curious to know, what do you do? Do you have enough data? Do you need more? Is this like a challenge in the field of social science that there's just not enough data to verify stuff?
Yes, definitely. I mean, and I think almost every social science study you'll read will end with, we need to study this more. And I think the nuance there is that in most every study, you're trying to find these kind of new ways to present the problem or the solution. And then along the way, you find that that really wasn't the best way to articulate. So I'm going to go back to Rebecca's study, actually. If I can find it. Because I thought this was just a really innovative way to approach exactly what you're talking about. So in the study, they talked about how there could be this problem of if people are answering this question, like, are they just answering the question like they're doing a, quiz at school and they just picked the answer that seemed the most correct? How do we know that that's how they actually feel? So in this study, they allowed for an open-ended write-in response, which I thought was a great way to uh, have them articulate another way of saying the same answer. So I think it's really, and this is all new. It's gonna take a lot of different methods of one study to figure this out. And I think the thing that I'm most excited about social science and earth sciences, which is also kind of a negative, is that it's not very regularly incorporating social sciences yet. So any research we do maybe like kind of the first time we're ever trying to ask a question in this way, So I would say in terms of validation, like we could keep asking questions over and over again and seeing if we get different results. But ultimately, social scientists tend to want to create new methodologies, so it's just going to be it'll keep being an iterative process until we've got a system down. Did that answer the question maybe?
Yep, it did. It did.
It's a lot. Yes, it's a lot of work to be done still.
Awesome. We don't have any more questions. I would like to thank everyone for coming to this Discovery Series seminar. Remember, you can check out these on the website and future talks at cpass.ucar.edu, and past talks will be uploaded to YouTube. Allison, thanks so much for sharing all this important work. I'd also like to thank Jessie Webb from UCAR Multimedia Services for her invaluable assistance. Hope to see everyone at the next seminar in December. Good afternoon.
Thanks, guys.